Hello everyone, I'm Rahul from the Fun Robotics Network, and here with me is Team 9881 Golden Gears, and they've had a tremendous season as one of the fastest sample bots in the world. Learn more about their speedy yet consistent intake system, their very effective transfer, and their fast outtake slide on Behind the Box. Alright, welcome Team 9881. Why don't you guys start out by talking a little bit about your design choices and your strategy for this season?
Yeah, so our very first look at the game, we saw that samples were worth a lot more points because you could cycle them much faster than specimens. So we decided that we were going to try and just be the best sample cycle possible and just purely optimize just for samples and not really focus on specimens at all.
Nice, that's really interesting. Now, obviously, a lot of teams this year have been going with that pocketed aluminum drivetrain. What was your decision behind going with the full wood drivetrain? Because it's a really unique idea that not many teams have done.
Yeah, so the main reason why is because we have a laser cutter, so we're able to easily cut these plates. And for the loads and the loads that in FCC, you really don't run into that much stuff that would break wood, and so you don't really need the additional strength that aluminum provides. It's also much more cost efficient to just buy, like, say, bulk, like 10 sheets of MDF, which is what we use, than to have to get like custom like aluminum for each plate.
Nice. That's really interesting. So now let's just jump straight into the robot. Why don't you guys talk to me about your intake system and show it in action?
Yeah. So our intake right here is we got a direct driven 4.8 volt go build at super speed, and then we just have two just like surgical tubing wheels. And then when it extends out, it'll spin. It doesn't have to spin that fast because our intake box is sort of designed where it's able to vector it in pretty easily. So it's able to just quickly grab it, and then we flip it up on a V-bar, sort of align it with the sample, and then when we bring it back, the impact of the extension retracting sort of seats it fully at the back, where then we can just grab it with this pretty easily, and then we're able to lift up.
Nice. Now that's really interesting. I'm just going to go into each component. So first, your intake. Obviously, I really like how it's on a virtual floor bar, which means it's always parallel with the ground. And it's so simple, yet so effective in the matches. How many intake iterations has it gone through, and what suggestions would you have for teams looking to implement a similar active intake? Yeah,
so the body of this intake is on its second version. So this is our second version, the whole like plastic shell. But these MDF plates, this is probably version like 7 or 8. So we constantly change the distance between the length of the rollers, the distance between them and the ramp, and how far they are above the ground, just to get a consistent intake that's able to quickly grab the samples.
Nice. Yeah, I think that optimization is really important for teams. Have you guys run into any issues with the intake only being powered by one, looks like a go build a super speed servo, or do you think that's fast enough for you guys?
Honestly, it's fast enough because we don't have to pivot. If it's a pivot, and if it had to power a counter roller as well, then it might be a bit too much force. But our intake is very efficient because it sort of pulls it in, and there's really no wasted movement. So we don't actually need the actual speed, and it's perfectly fine. It's just 180 RPM.
Nice, that's really good. Now, why don't you guys walk me into your extendo system? So obviously, I see you guys have got the linkage. What was your decision behind using linkage and not string? And I see you've got these polycarbonate linkages. What played into your ideas right there?
Yeah, so we started off just looking at, hey, we can just put a slide on the robot. It's really simple. And actually packaging the motor to power this is pretty complex, but you can literally just put 2 servos in a servo block and then a 2-bar, and then it just works very consistently. And the main advantage of, or the main disadvantage of servo is that you can't really be as precise because it's like a non-linear movement, but we really just extend all the way out and then use the drivetrain to align more.
Nice. Now, let's go straight into your transfer system. So a lot of teams I've seen who are doing a transfer have picked up the sample from the top, but you guys are picking it up from the back, which I think has made it really unique and really effective. What was your decision behind that, and why has that helped you guys this year?
So the main reason why we grabbed the sample from the back is the sample fell down there. But when we grab it from the back, our intake will be able to sort of hang over the bucket, and that will allow us to be able to place stuff more effectively. So if you grab it from the side, you can really only place about 16 or 17 before it starts to just completely fill up the bucket. But if you sort of place it horizontally, you can stack upwards of like 23 or 24 just onto the bucket itself.
Yeah, I think placing more samples in the bucket is really important. That's going to be key at high-level competitions. Now let's go into your outtake arm. So I see it's a long arm. Is it just driven by one Axon Max servo?
Yeah, it's just driven by one Axon Max because it's very light. It's just a servo and then just 2 herringbone claws. and then just some wood plates. And it's just light enough that it's able to just quickly go. And also, since we only have to use one axle, the whole lift is going to be much lighter as well.
Nice. Now, on the topic of your lift, so I see you guys got a couple unique things. First of all, you guys seem to run belted slides, which are pretty unique compared to a lot of teams that run string. And you guys seem to have some sort of milled or inserts rather than the 3D printed inserts that a lot of teams had. It looks like some sort of aluminum inserts. Yeah. What was your decision behind using aluminum inserts and that idea?
Yeah, so these aluminum inserts, this is the first slide I made, and it's just really simple packaging. You don't need a collar, you don't need anything. You sort of just put this on, put the pulley on, and then just put this part in the vise, and then that clamps it so that the pulley then can't really come out at all.
Nice, nice.
Yeah. And one of the reasons why we use belts is because strings can break. And although some people have had success with strings not breaking at all, we just don't want to run the risk of it breaking at all. And belts just cannot break with the FTC loads.
Have you had any issues with belts skipping, or do you have any problems with that early season or anything like that?
No, because we haven't really had any issues with skipping because we have the full like 200 degrees of wrap, about maybe a bit more. And also these motors are 1150 RPM on a 38 millimeter spool, and that means that that means that there really isn't enough torque to actually slip them. So even if we do accidentally go for like a level 4 climb, it still is not able to skip it just because there isn't enough torque to skip it.
Nice, nice. Now I see you guys have got this other claw on your outtake slides. What is that? Is that for specimens, and how does that work into your design?
Yeah, so we originally decided that we would have this spec claw, and then after endgame we would start doing specimens. But then after we implemented it, we realized that it was actually faster to just do low bucket cycles. So we haven't really used this in a while. But it's still used sometimes when we run a 1-spec 3-sample auto, but we haven't been really running that recently.
Nice, nice. That's really interesting. So now I think this robot is really amazing and has some really high scores thus far this year. What are your plans for improvements as you go into the SoCal regionals and as such?
Well, one of the issues is that this robot is very bulky, so it's 16 by 16, and that's really important because when you want to be able to just intake samples consistently, you can't really be running to any defense. When your robot is really big, it's more impacted by defense than a small robot, because a small robot can sort of fit in the gap. But if you have a big robot and they park themselves in the middle of the ascent zone, then you just can't really intake as well. Another thing that we would do is, right now we're limited as to how many samples we can grab. So we only have about 360 millimeters of extension. And so we're planning to add a lot more extension and maybe use a motor as well, so it's still fast.
So do you plan to switch to string-based instead of a linkage for your second version?
Yeah, I think we're going to be using belts, just because I do have a lot of experience using belts, and I prefer them a lot more than strings do.
Nice, nice. That's really interesting. So thank you so much for this amazing Behind the Bot with Team 9881 Golden Gears, and I'm Rahul reporting from the Fun Robotics Network. Thank you.